In this video, we'll be discussing the ideal gas equation as well as deriving the formula for the ideal gas equation. Let's get to it. Let's discuss the concept of the ideal gas, okay? So when we say ideal gas, what's an ideal gas? An ideal gas is another name for a perfect gas, okay? Now note this, when it comes to gases, there are four quantities that are important in all experimental work, measurement, or calculations involving gases. They include number one, volume, which is generally V. Number two, pressure, which is P. Number three, temperature, temperature. Number three, which is T. Then finally, number four, we have the amount of substance or the number of moles. Number four, the number of moles, that's N, or mass. All right, number of moles or mass. So these are like four very important quantities in all experimental work, measurement, or calculation involving gases. Now, from our previous class, we talked about two important laws that governs the concept of gases. The first one we discussed was the Boyle's law. We discussed the Boyle's law, where we said from the Boyle's law, we derived the equation P1 V1 is equal to P2 V2. We got this from Boyle's law. We also discussed about Charles' law. All right, we discussed the concept of Charles' law in our previous class. And from Charles' law, we said V1 all over T1 is equal to V2 all over T2. Now let me call this here. I'll call this our first equation, equation 1. I'll call this a second equation, equation 2. If I combine Boyle's law, that's from equation 1, and then Charles' law from equation 2, from equation 1, you can see that we have pressure times volume. So I have P1 V1. From equation 2, we can see that the volume is being divided by temperature here. That's all over T. So we can come here and divide this one here, divided by T1. This has been equal to, now repeat the same thing on the right hand side, which is P2 V2 all over T2. All right. So if I combine Boyle's law and Charles' law, would have that P1 V1 all over T1 is equal to P2 V2 all over T2. So we'd have this. Now, if you looked at our previous classes when it comes to the concept of Charles' law and Boyle's law, you'll notice that if I have the same kind of equation on the left hand side, that's this, and on the right hand side, that's this of an equation, I can simply take out the parameters, which are P, V all over T, and equate it to a particular constant. In this case, the constant we'll be using here is R, where R is called the molar gas constant. Okay, the molar gas constant. All right, so this also works there. All right, if I have the same thing on both sides of the equation, as you can see, P1 V1 over T1 being equal to P2 V2 over T2, I'll just take out the 1s and 2 and just have PV over T. It's equal to, I'll equate it to a constant. In this case, we're using R as my molar gas constant. Okay, from here, if I cross multiply, that means T comes this way here. So I'll be having PV is equal to T multiplies R. I'll have RT. So you have this particular equation here. Now what you have here as being PV being equal to RT is called the, now what you have here, PV, what you have here, so you can say this, you have PV equal to RT. This equation you have here is called the ideal gas equation. That's PV being equal to RT is called the ideal gas equation, and it holds true for all gases. Now, what to note is that the above equation, which is this, applies only to 1 mole of a gas. All right. So if you have PV being equal to RT, it only applies if I have just 1 mole of a gas. What if I have multiple moles or a number of moles of a gas? What if I have for, let's say for n moles of a gas? So this is the ideal gas equation for 1 mole of a gas. That's for 1 mole of a gas. What if I have more than 1 mole or less than 1 mole of a gas? What would be my equation? Now, I said the above equation only applies only to 1 mole of a gas. For n mole of a gas, we'll get that the general form of the equation will be given by PV, that would have PV being equal to N times R times T, where N is equal to number of moles of gas. So N is equal to the number of moles of the gas. So we'd have this. All right, so we have this. Now, if this is true, that means for n number of moles of a gas, then the ideal gas equation is given by PV is equal to NRT. So we have this. So now have this, 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 and this. So this is ideal gas equation for n moles of a gas. All right, so let's define each of these parameters where P is equal to, as we said P is pressure. Okay, now P is pressure. In this case, pressure is measured in ATM, right? ATM means atmosphere. Okay, write that down. ATM equal to atmosphere. That's it. V it's equal to volume, and volume in this case is measured in decimeter cube. So I'll just write this as in dm cube, decimeter cube, or liter. Okay, or in liter. Now note that 1 decimeter cube, that's 1 dm cube, is equal to 1 liter. So I'll just use 1L. 1L means liter. So whether you see decimeter cube or liter, they mean the same thing. T is temperature. Okay, T is temperature in Kelvin. In Kelvin, that's K. And of course, N, as we said, is equal to number of moles. Number of moles in MOL. All right, so this is what I have for this. Now let's look at what about for standard temperature and pressure, all right, or at ST STP means standard temperature and pressure. Okay, so as standard temperature and pressure, the value of temperature, the value of the pressure, and the value of volume has specific value. Right, so at STP, the value of the volume V is equal to 22.4 dm cube. Please note that this is a constant. Okay, also, at STP, the value of the pressure at STP is actually 1 atm. Again, this is also a constant. Okay. Then finally, temperature at STP, that's standard temperature and pressure. The value of the temperature is 273 Kelvin. So we have this. So at STP, note that the volume is 22.4 dm cube. The pressure is 1 atmosphere and the temperature is 273 Kelvin. Then we have this. So at STP, let's look at what would be the value of R for 1 mole of gas. So for a mole of a gas, for a mole of a gas, when we say a mole of a gas, it means number of moles, N, is equal to 1. At STP, what do we have? Would have that PV, the equation was that PV is equal to nRT. So at STP, we said the value of the pressure is equal to 1 atmosphere, so 1 as pressure. In the value of the volume in at STP, we said it's 22.4 decimeter cube. It's equal to, when it comes to N, number of moles, we said for just 1 mole of a gas, so it becomes 1 times R. We want to get the value of R at STP for 1 mole of a gas. Then finally we have T. T is temperature. At STP we said we had 273 Kelvin as my answer. Let's find the value of R from here. What do we do? 1 times 22.4 gives you 22.4. It's equal to 1 times R times 273. Simply becomes 273R. 273 R. All right. To get the value of R, I'll divide both sides by 273. All right. So if I do that, I would have this as being, so I'm having this as 22.4. So 22.4 divided by 273 is equal to 273 R divided by 273. From here, this cancels this. I'm having R. So you have the R, it's equal to, now let's see what we have here, 22.4. So I have 22.4 all over 273. If I divide this, now what you have here is equal to 0.082. This gives you 0.0. You have 82 approximately. Let's get the units. Now, in getting unit now, what would be the unit for R? If you look at this carefully, you can see that from here, if we have something that looks like PV is equal to nRT. To get the value of R, divide here by NT, divide here by NT. So this will cancel this and this. So you have R. R is equal to, I have pressure. The unit for pressure is actually atmosphere. So it becomes ATM, atmosphere. Then you have volume. You can see this volume. The unit for volume is actually dmq. So atmosphere dmq. Okay. Next up, what you have next is no amount of substance, that's in mole times temperature. Observe that temperature here is now a denominator, so it will come with a -1. For temperature, the unit is Kelvin, so it becomes K to the power -1 because it's a denominator. And then finally, you now have N, amount of substance, which is what there? Mole is still a denominator, so it comes with the word there, -1. So you have this. So hence, the value of the molar gas constant is actually 0.082 atmosphere dmq per Kelvin per mole. So we have this. All right, so this is how you derive the value of this. Now, having done this now, let's take out some past questions, or let's take some questions on the ideal gas equation and try to solve them. Let's look at question 1 here. Question 1 says a certain amount of gas occupies 8.0 dm³ at 5 atmosphere and 225 degrees Celsius. Calculate the number of moles present. Okay. How do you solve this? Solution. First task, as usual, is to list out given parameters. Okay. Let's list out parameters. So solution. Given parameters. So given the first we are given the number 1. They said a certain amount of gas occupies 8.0 dm³. Now we said dm³ is simply the SI unit for volume. Volume V is equal to 8.0. That's the same thing as 8 dm³. So we have this. So that's my first parameter. They said at 5 atm. So number 2, I'm given pressure. Recall that we said pressure in this case can be measured in atmosphere. Pressure P is equal to 5 atmosphere. Okay. Next will be said and 25 degrees Celsius. So number 3, I'm given the temperature, right? Temperature, that's T as equal to, what I'm given here is 25 degrees Celsius. So I'm giving this as 25 degrees Celsius. Now we said we'll convert the temperature from degrees Celsius to what's there? Kelvin. That means T is equal to convert this to Kelvin, it becomes the value there, which is 25. You add 273 to the value in order to convert it to Kelvin. So I'm having this. So if I get my calculator there, I'll point 25 plus 273. And if I do that, I have my value here as 298 Kelvin. All right. So I have 298 Kelvin as the temperature. All right, what else do I have there? They said calculate the number of moles present. So you have to find n. Number 4, number of moles present, n is equal to unknown. We have to find that. And luckily, they gave us the value of r. Now, note that you would not always be given the value of r. You would not always. All right. So if you're not given, you should know it because it's a constant. Anyways, they give us r, number 5. They give us r, a constant, that's the molar gas constant, as being 0.082, right? 0.082 atmosphere dm cube per Kelvin per mole. All right, so you have this. All right, so with this check, let's now get the value of n. Now let's recall our formula from the ideal gas equation. From the ideal gas equation, what do we have? We have that PV is equal to nRT. Let's start with P. For this, we can see that P is 5 atmosphere. That's the unit. So it becomes P5 in atmosphere into V. V is volume. From here, the volume is 8. So into V is 8 is equal to N, number of moles, which we asked to find, into R. R is 0.082, a constant, and then T, right? 0.082, okay? And then T, 298. So this gives you 298 in Kelvin. From here, let's find the value of N. First things first, 5 times 8, that gives you 40, okay? That gives you 40 is being equal to n into, let's punch this, 0.082 multiplied by 298. That gives you 24.436. So we have this. All right, to get the value of n, I'll have to divide here as well as divide here by 24.436. Divide here by 24.436. So this will cancel this. All right, so we'll now have the n would now be equal to, we'll just punch 40 divided by 24.436. 40 divided by 24.436. All right, so if I punch this, my answer gives me 1.64 approximately mole. So hence the answer to this question is 1.64 mole approximately. We'll take one more question for this class, and let's look at our final question. All right, let's look at one more question for this video. The question here says, question 2 says, 5.0 moles of an ideal gas are at a temperature of negative 15 degrees Celsius and a pressure of 4 atmosphere. What volume in dm cube, that's decimeter cube, will the gas occupy at that temperature? Okay, in this case, we have to find what's that volume. You ask what volume, so we have to find volume. As usual, solution. Right, solution, our first task. So solution, our first task would be to list out the given parameters. So what and what am I given? So look at given. So given number 1, they said 5.0 moles of an ideal gas. All right, so number of moles, I'm giving number of moles n as equal to 5 mol moles or 5.0. Okay. Number 2, they said are at a temperature of negative 15 degrees Celsius. So I'm giving temperature T as equal to negative 15 degrees Celsius. Let's convert this to Kelvin. How do you convert this to Kelvin? It becomes negative 15. You add 273 as usual. Okay. I'm having negative 15 plus 273. If I punch that, negative 15 plus 273, you have 258. Okay, Kelvin. All right, so to convert from degrees Celsius to Kelvin, simply add that value to 273. All right, so I have 258 Kelvin. Next up, they said, and the pressure of 4 atm, that's pressure number 3. I'm given by 3, pressure P as equal to 4 atmosphere, so 4 atm. Okay, What's volume in dm cubed? So I have to find the value of the volume. Volume V, number 4. Number 4, the volume V is equal to unknown. You are given the value of R as 0.082. All right, so let's get our formula. The formula there is that PV is equal to nRT. We have to find the volume. P, the value of P, as we can see, is 4 atmosphere. Okay, volume is unknown, is equal to N. From here, we consider the value of N is 5 moles. That becomes 5 into R. R is 0.082. That's the value of R. And then finally, we have, of course, it's a constant, 0.082. That's this one here. You can see this one here. Then finally, we have the value of the temperature converted to Kelvin. You have 258, so 258 Kelvin as your temperature. All right, from here, let's get the value of V. Let's get the value of V. So we have that 4V is equal to, you have 5 times 0.082, 5 times 0.082 times 258, excuse me. All right, so if you punch this, you have 5 times 0.082 times 258. You'd have your answer as 105.78. To get the value of V, I'll divide both sides. Divide this and also divide this by 4. Divide this by 4. This cancels this. So the value of the volume V is equal to this value here divided by 4. Let's see. All right, 105.78 divided by 4. I have my answer to be 26.45 approximately. Don't forget this will be in decimeter cube. All right, so this becomes the answer to the question. That's 26.45 dm cubed. So that's how you solve this question. Okay. All right, I'll give you a quick question. Leave your answer in the comment section. Let me drop a quick question for you. All right, so a quick question for you. The question here is this. From the ideal gas equation, we have that PV is equal to nRT, as we said, and as we've derived in this class. Now, your question is this. What is the unit of N? All right, what did we say is the unit of N? So pause this video, give the unit of N in the comment section. All right, so leave your answer in the comment section, and I will tell you if you're correct or not. All right, the question is simple. From the ideal gas equation, PV equal to nRT, what is the unit of N? Leave your answer in the comment section, and I'll tell you if you're correct. Okay. All right, guys, don't forget that I prepared over 100 classes for JAMB and WIAC candidates, right, which covers over 100 topics in physics, chemistry, mathematics, and other subjects. Okay, for each of these 100 classes, I've prepared past questions and answers for the last 10 years. Okay, so you can get the course from my website. Simply visit www.journalimanual.com/courses, and then you see the JAM/WIAC course. Okay, simply register an account with the website, and then you can proceed to get the course, or you can simply join my channel membership to get access to exclusive content for JAM and WIAC candidates. Okay. All right, guys. So if you enjoyed this video, don't forget, as usual, hit the like button. All right. So like this video, hit the like button, leave a comment. For your comment, I gave you an assignment where I said you should tell us the value of N, the SI units for N. All right. Leave it in the comment section, and I'll tell you if you're correct. Also, don't forget, if it's the first time here, or if you get to subscribe, please do well to hit the bell icon. All right. Subscribe and then hit the bell icon. Select all so that you get notified whenever we upload a new content. Then finally, share this video to your friends so that they can also learn. Thank you, and see you in our next class.